So that's why you are getting this sort of curves. Okay, this is the dashed curve is for n is equal to 1000, a is equal to 50, and this curve is for n is equal to 100 and a is equal to 5. Okay, now uh, all these curves, including the ideal OC curve, pass through the point 0, 0.05, 0.6160, this point, because all the curves have the ratio of A and N equal to the proportion defectives in the lot, that is 0.05. Okay, so the A by N ratio, this will be fixed for all the uh, you know in A by N is fixed for all these cases. Okay, so that's why they have passed through the same points, same point. Okay, in this particular case. Now you can see that the effect of sample size and acceptance number, and these curves are actually based on I will tell you that these curves are actually based on here, these are based on the Poisson distribution, which is very mostly used. The Poisson distribution is very frequently used. Now the effect of sample size and acceptance number on OC curve. As the sample size increases with lot size and acceptance number remaining constant, the OC curve becomes steeper with more discriminatory power. So you can see that in the lot size, all the cases they are fixed 2000, but small n C, the acceptance number or the cutoff number, that is also fixed. But small n, that means the sample size is in here, you are increasing the sample size. Okay, as the sample size increases, okay, the OC curve, it is becoming steeper and steeper. Okay, this is steep, this is very steep. Okay, you can see it will become steeper and steeper. Now conversely, as the acceptance number decreases with lot size and sample size remaining constant, the OC curve becomes steeper. So in this case, what is happening? Your n, the lot size, it is fixed. For all the cases, it is capital N is equal to 2000. Small n is 50. Okay, that means sample size is also constant, fixed. And the cutoff number or the acceptance number, you are decreasing. So as you decreasing, the curve is becoming steeper. So this is the effect of sample size and acceptance number on OC curve that we can see. Okay. So in the next class, we will describe the concepts of producer's risk and consumer's risk. Okay, this is very important, and we will also describe that how to draw the OC curves in Excel. Okay, so that I will describe. I will just give the example of Poisson distribution, okay, because it is very frequently used. But in the same way, also the binomial, for the binomial distribution, and for also the hypergeometric distribution, the OC curves can be drawn. You can go through your book to see that how these curves are drawn. And not only that, but also uh, mm, uh, I will give the example for one step for single sampling plan, but also how to do these things for double sampling plan, that you will also find in your book. But in case of multiple sampling plan, you won't find it. There are in books, there are many research articles on it, on this particular issue, that how to do. You don't need to know those things, but just I will give the simple example of the single sampling plan, and one example that how these curves are drawn. You need to have this idea. That's it. Okay. So I'm going to stop the recording.